You're watching Meet the Astronomers on Astraveo.
Hello there. Welcome to Astroveo's Meet the Astronomer series, where we talk about the most interesting parts of astronomy, the people. We're going to meet and greet a whole slew of people doing the actual work in astronomy. We're talking instrument builders, telescope operators, professors, early career scientists, postdoctoral researchers, program managers, and citizen scientists. This is absolutely fascinating for me and Joseph because we get to meet a vast array of people on our travels when we go to telescopes or conferences. We meet people from different cultures who speak different languages, who eat different foods, and sometimes grew up seeing different stars than we did if they lived in the Southern Hemisphere, for instance. So this is a lovely, lovely series. We're going to really get to meet some thoroughly interesting people. We're going to hear some stories that will make you laugh, some that might make you cry, but most of all, they'll make you realize the absolute fascination that the human race has with astronomy and its astronomers. All right, let's get started. Good evening. Welcome to Astroveo's continuing Meet the Astronomers series, where I have the great pleasure of introducing an old friend and colleague, Dr. Richard Anantua, who I met several years ago in the Event Horizon Telescope project. Richard is a theorist, so does stuff way harder and more complex than I can possibly understand. It means he's very good at mathematics and modeling and understanding the universe in ways I can't. So it's wonderful that you're here with us, Richard. I think we've discussed this already. Richard's going to talk about a little bit about his life, his science, what he enjoys doing, and really just so our viewers can understand you as a person, you as an astronomer. And for me, it's a thorough pleasure for you to be doing this with me. So
absolutely,
thank
likewise.
you. I appreciate it, man.
It's been a while.
Has been a long time. I'm glad we had a chance to catch up. So you know yourself way better than I do. So would you like to say a few words about yourself and how you like the world to know you?
Yeah, and first, thanks for doing this. Thanks for putting people to the equations that we see in papers. A lot of the heroes that I had growing up were in books like Makers of Mathematics, Men of Mathematics, when they were allowed to title books that way.
Absolutely.
And I was really inspired by the biographies, even though I wasn't always at the top of the curves when I was doing math and majoring it at some point, and just kept pursuing different challenges. But maybe to start chronologically, I grew up in Brooklyn, New York.
Yep.
And I grew up in the projects in Canarsie, so that's awesome.
Okay.
So
a quick question: pizza from New York, pizza from Chicago?
I think I outgrew pizza at this point, but New York. Anyway,
New York. Okay.
Yeah.
Sorry to interrupt.
Yeah. So I grew up in Brooklyn, and I happened to have an environment that was very rich in old textbooks, old encyclopedias. So I had an uncle who used to collect a lot of these things and bring them to my mom's apartment. And he didn't always have a place to put things, and he sometimes needed storage. So the convenient thing to do was to just leave them with my mom. And as long as I can remember, I was always able to read encyclopedias and read atlases. So these were often pretty old encyclopedias, like World Book encyclopedias from the 1950s.
Wow.
And we also had a number of textbooks and all sorts of really interesting nonfiction just at my disposal, and there was tons of it. So I just spent a lot of my childhood delving into that. And it was actually more compelling than things like video games. I had a cousin who was a lot better than me at video games. um, so just having that as a distraction was a very, I guess, fortuitous circumstance, because I was able to just get ahead on math, on science, a lot of the things that would help me eventually test into math and science schools.
Yeah.
So from 5th to 9th grade, I went to 5 different schools.
Holy cow.
And a couple of them were magnet schools in New York City, so Hunter College High School and Stuyvesant. So these are schools that were just very competitive exam schools, and usually people got into them through very different means than just having a lot of hoarded books for a very long time. So usually that took a lot of different extra means of preparation, whether it's after school programs, Kuman, whether it's tutor. But for me, it was just a pastime, and it was just what I was interested in from very long.
Okay, so what you're basically telling me is you're a genius.
I don't know. Maybe it's the opposite. Maybe I just had a lot more time than most people to do the same thing.
Maybe both. How's that?
If you will, it's your podcast.
Well, no, I happen to know you're a very clever guy, so. Well, that's really cool. And so moving forward a little bit, where did you go to college?
I went to Yale for undergrad, and I ended up majoring in physics and philosophy as one major, math and econ as another. So I, just happened to compress a lot into 4 years, and I did play sports. I did some rugby there.
Did you?
Yeah.
I didn't know that.
Yeah.
So I don't know if you noticed, rugby is the national sport of Wales.
Oh, yeah. You guys do Six Nations.
That's right, Six Nations. We're not very good at the moment, but throughout history we've been decent. What position did you play?
Mainly flank.
Oh, okay. Well, you're a big, strong guy. So yeah.
I mean, if he's not going to make us stand up, but he's about 6 inches higher. So
if you're 6 inches wider,
okay.
Okay. So that's pretty cool. I know something interesting about you.
Okay.
So
I did not know that.
Yes, indeed. Well, I know lots of interesting things about you. But at home, I speak French to my children. You speak French and Haitian Creole.
Yes.
So where did that come from?
Well, my mom and dad are from Haiti.
Mm-hmm.
At my household, that was the main language spoken.
Interesting.
And you speak Haitian Creole as well, or more French?
It's more French.
More French. Okay.
I can understand, but obviously the things like the sort of patois part, the Creole part, I don't know as well. I mean, I've heard.
What's your favorite Haitian food, or if you have one? Or
it's sort of like I can't remember the name of it, but there's a spiced rice. Like chicken rice, it's like an orangey yellow spice.
Okay, that could be any Caribbean island. But yeah, I was hoping you'd say banan peze or lambi or griot.
Yeah.
I guess I still have some from visiting my mom for her birthday recently. So
great.
Yeah, so I can reintroduce you to it. I probably don't have the rice, but we have sauce pois, which is black bean sauce on the rice. And you grew up in the UK and spoke French and English because.
Well, it was a bit weird. So I grew up in Wales and Germany. I was born in Germany, but in Wales,
that's still in the UK, right?
Wales is part of the Great Britain and the UK. Yeah.
Yeah.
But in Wales, we grew up speaking Welsh and English. And I loved Welsh. It's a very old language. But unfortunately for Welsh, when French came along, I just fell in love with it. It was such an elegant language. And then I used to visit France, and I did my second postdoc in France.
Nice.
Université.
They were still doing 2 postdocs back then. Oh man.
Well, I'm a bit older than you, so yeah, that's right. So my first postdoc was in St Andrews, but my second was in Grenoble in France. And when I went for the interview, I actually gave you have to do a presentation to the group. I gave it in French. And wow. You're the first person that's ever done that. So they must have liked me for something.
I saw the movie Oppenheimer, and when Oppenheimer was visiting Niels Bohr, and he gave a talk in Danish.
Really? Wow.
I think
that's not a very common language.
No, it wasn't Danish or Dutch. I mean, he was visiting somewhere, and he gave a talk in a language that's spoken in mainly a small country.
Yeah. Well, I mean, both those countries have got fairly small populations.
Yeah. But so I mean, you were already speaking French for quite a few years before that talk, or? Yeah,
that's right. So so about 10 years. But,
so if they make a movie, instead of Oppenheimer, make the movie James, they can embellish a little bit and have you give your talk in French after learning it, a week or two ago.
That's right. I suspect they'll never make a movie of my life. Maybe they will of yours, because I think you're cleverer than me. But well, this is really interesting. So this is the part I love about this series, is people get to know the real person. And I will talk some about your science, but the fact that you've got this background of grew up in sort of New York as melting pot of a load of cultures.
On certain scales, it's just completely homogenous. But
that's the same as everyone, right? But to have, essentially trilingual, which is just wonderful. I love that. That's beautiful. I'm going to Yale, pretty impressive school, and they've got a nice program there.
For what?
For astronomy. I happen to know they're good at, so there was something called the Yale models, the stellar models, where they produced mathematical models of the sun and stars like the sun, from basically their birth line all the way through to the old age. And the Yale models are pretty famous, they're well quantified now. So. Okay, an interesting question, because if you grew up in Brooklyn, I suspect you didn't see many stars. How did you become interested in astronomy?
Well, the math is the underlying part of pretty much all of natural science. The world that we see around us are applied versions of pure math. So I think that we're naturally wired to want to understand how things work at a fundamental level. We just get naturally curious about how the universe got to be where it is, where it's going, what it's been. I think that if we weren't, we wouldn't have a lot of this modern technological society that we are living in.
I agree.
It takes a lot of curiosity to dig into exactly how electrical currents work, or if you fly a kite and lightning strikes it, even if the story is apocryphal, if something similar to that happens and you don't follow up with it, then the fate of you is going to be at the level of the fate of almost all the other species that are not at the top of the food chain.
Yeah.
So whatever selection effect got us to where we are, it will make us typically very innately curious about the natural world. So it's more of a matter as to why some people stop pursuing their natural interests than why people are interested in it in the first place.
Absolutely. Couldn't agree more. And this might put you on the spot a wee bit. If we went out tonight, would you be able to spot Venus, or could you identify?
I thought you were going to say if you're going to spot me for like a meal or something. I was like, yeah, absolutely. You came all the way down here.
No. I should buy you dinner.
Well, I would, because I have the Star View Light app.
Oh, that's cheating. Okay,
but yeah, it's going to be the brightest thing that you see. So yeah, you can test me on that. Okay. So I would be able to find it if these clouds let up.
Okay, well, I'm going to ask you an academic question here, so be careful. Your students may end up seeing this. We should also mention Richard is a professor at the University of Texas, San Antonio, so he has a lot of students. How many constellations are there?
Constellations are broad regions of the sky. They're not necessarily discrete sets of stars. How many discrete regions in the sky would you? I'm gonna just go off order 10. I'm not gonna really
That's okay.
Pin it down. What answer were you looking for?
Well, the real answer is 88. Now I'm showing you up because this is
order 10.
You said order 10. You were close, right? In astronomy.
Yeah, I teach order of magnitude physics, so sometimes.
No, of course. Yeah.
That would be an admissible answer.
Of course. Well, I have to say for our listeners, me sort of showing you up about observational astronomy, you could show me up in a million ways with theoretical physics and mathematical treatments of things. So let's not do that, because I will look really silly.
And by the way, I'm taking order 10 to be between 10 and 100.
I know.
So but you can answer to that level of.
Yeah. I love observational astronomy, right? I'm a geek of telescopes. You know that. So.
I mean, we're fine. What's the grand unified scale?
Okay, I see that too.
But you can answer it to order of
grand unified scale.
EV or some.
Oh, geez. No. So I'm going to edit this part out.
You could say 10 to the something EV, and then you'd be fine.
Oh my gosh.
Okay, just
10 to the 54.
I think it's less than. But let's.
No, it's good. It's good that you quiz me back. I'm quizzing you. I'm going to have to look that up afterwards.
Mhm.
Actually, do you know the answer? Of course, you know the answer. Roughly.
I'm not going to. I was thinking 10 to the 38 EV, but I could be thinking about another number.
Yeah, there is. You're right. There is a 10 to the 38. I can't remember what it is, but I'm sure you're much closer than I am. Within that's 14 orders of magnitude right there. How did you become a professional astronomer educator?
Yeah, so that's actually a good question to follow up. Why we're intrinsically interested in something, and then sometimes people don't, fully realize that as a career path. But sometimes people do. So um, I did have this head start in that I was really hitting the physics textbooks. Just high school physics textbooks, Survey and Fawn, or there's a lot. All of these are in my apartment building, and I just spent a long time since elementary school just going through them. So getting the head start made me competitive in being able to test into many different schools and test into a program called Prep for Prep in New York City, which lets you, even if you don't have great financial means, to be able to go to a private school. So one year I went to a Packer Collegiate private school in Brooklyn, and then the years sandwiching that I went to Hunter and Stuyvesant, and get the extra training from Prep for Prep. So I just had a lot of time spent doing the things that made things second nature to me when I was taking some of the exams that you needed to get to the next level. And now it's changing, so there's not necessarily as many required exams. I think that they might be even getting rid of SATs at this point. But
really?
Yeah, they're getting rid. So the procedure's a little bit different, but having a lot of preparation before you even knew that you would uh, benefit from being prepared was quite helpful in being able to um, go through the logistical obstacles and get a sufficient grade point average to be competitive. And I tended to make study programs that were driven mainly by my curiosity rather than uh, just doing what's prescribed for me. That was a traditional path. So I don't know if there have been any other physics and philosophy and math econ majors at Yale, but I knew that I wanted to do physics, ever since I was, in high school, before any physics was formally taught. But I ended up having that. Effectively, the intensive physics major was a subset of the courses that I took for that two joint major program that I ended up making for myself. Um, and I got into publishing very early in my career. So after sophomore year, that was when my first paper, and it was a physical review letter about primordial black holes, came out.
Really?
And that's when it was that was the project took place. But then the actual editing and reviewing took another year. But still, as a sophomore, I had this research project from a cosmologist named Richard Easter, and
so you were 16?
No, as a sophomore in college.
Oh, in college. That's not high school.
No, when I was jumping back from actually, fast forward, I actually did work with a high school student in the San Antonio area, and he did publish a paper with me while he was still in high school.
That's
so
amazing.
I did try to return the favor and
pass it on.
Yeah. If I'm allowed to use his name, is Nathan Nata.
Excellent,
And
of course.
Yeah. So, but for my case, how did I end up getting selected? Well, there's a lot of things that go on behind the scenes that I'm not privy to, but the preparation that I had ever since I was growing up was always very helpful, and it always left me in a ballpark where I could have competitive GPA and the scores that I would need when they actually still had the exams to just be considered. But that's being considered is not enough. So other things that I did, I mean, I made my own programs in a way that not many people did. So I probably stood out in the you know the two papers that I had as an undergrad were one that primordial black hole as a source of stochastic gravitational wave background. You said no jargon, but you can edit that out if you wish. But then another one was about um, beyond the standard model photons coming from very distant BL Lacertae objects, a very, very distant near line of sight quasar type objects. So having already a diverse portfolio of research, diverse portfolio of what I studied, it probably made me look a little bit different. Also, probably my background. So the people typically taking the courses that I was taking had probably quite different household situations. If you want to make inferences from what Yale's socioeconomic breakdown was at that time. So, for instance, in the Yale Daily News, I remember at Commons at Yale, the dining hall, opening up the Daily News on an article about what the family income breakdown was at Yale, and they had top fifth, 500,000 and above. Roughly the next fifth being 250,000 and above, and then the lowest quantile that they had just was like 80,000 and below, and I was like, they didn't break it down below that because my household income around that time was more like in the 20s, 20,000s, but they just had like the last they didn't really break it down below that, and later on there were articles in New York Times about the share of people from Yale coming from the top 1% versus the bottom X%. So here's another quiz question. So the top 1% at Yale is as represented as the bottom X% in terms of family income, circa 2010 or 2015. What would X be? What would the bottom blah percent be compared to how much the top 1% is represented? So how many, what bottom, bottom 10th, bottom 20, bottom, etc. Like
of the lowest medium income for the household income?
Yeah.
2%.
No, it's like so the bottom 60% was as represented as the top 1%.
Oh, I see.
In the class. Does that question make sense now? Or
no? So does that mean lots of people on scholarships?
No. So what is the share of Yale undergrads who came from the top 1% of household income is equal to the share that came from the bottom 60% of household income. So if it were completely, income neutral, then you would expect, if you take someone at random with respect to the income distribution, and you were to compare how many people ended up at Yale from the bottom 1% as the top 1%, then there would be equally many. But instead, you need the bottom 60% to make up as many people as the top 1%.
Oh, I see. So you mean the bell curve is way weighted?
Yeah. So your chances of being in the top 1% at Yale are way higher than they would if you were just picking at random from the general population. So the top 1% is as represented as the bottom 60% of the household income distribution.
That's incredible. So I don't know the actual number, but
that was me. I mean, that was the number from
60.
Yeah.
Gee whiz. Well, it is it's an Ivy League school. I think there's a lot of well-heeled people that go there. Let's put it like that. This is one of the things that's always fascinated me about you, Richard, is that you and I come from similar backgrounds in the sense that I don't know your family situation, but basically, it's, me, my mother, and my sister, and we were pretty poor growing up.
It's pretty much me, my mother, and my brother, but it's sometimes my dad was
occasionally.
Yeah.
Well, so that people who grow up in poverty, like we did, the chances of succeeding are really low, and one of the best ways out of poverty is education. Now, you know that yourself, and you got yourself educated through a lot of hard work, through, sounds like, the support of your mother, and you did it. And I was the same, me and my basically support of my mother and just reading books, But in this country in particular, you had and possibly still have a disadvantage I never did, because the average astronomer is a white man. So the fact you've overcome these obstacles to be in the place you're in is phenomenal. And you've always been a sort of role model for me for that, I'll be honest. I've always looked up to you for that. So, congratulations for sort of winning the game of life, because many don't. And so, I think we should not get into this too seriously, but the fact you've been able to overcome these obstacles is just phenomenal.
Well, I think that the most popular physicist in the world right now, in terms of recognition,
That's true.
Neil deGrasse Tyson.
That's true.
But in terms of the technical work and the technical achievement, I can think of actually a lot of, even a lot of Black astronomers that we could consider who are extremely technically accomplished. It's a mixture of charisma, public speaking, networking, circumstance, to become a scientist with a lot of notoriety, and is a lot of the technical barriers that are why a lot of the high schools or higher ed institutions that I've been to have very skewed demographics in their, in the advanced national science programs, are a lot of the reasons why the representation is skewed at the professional level.
Right.
So I think that there is a multi-pronged approach that should occur, where culturally, I think that we should be putting as much stock. If there's significance to group membership, and group membership can be influential in the type of role models that a group holds value for, then we could be making I guess, grassroots level push to support scientists and make scientists as popular as singers and
Right.
as athletes. Yeah, I think that there's some grass level activity that could really catch on, really go viral in a nonlinear way, and really just make a really drastic change in that way. And of course, there are effects that are due to the racial components of wealth gaps, and the amount of dependence on prior generations' ability to accrue wealth. And of course, in the United States, we had a history where just a few generations back, there were major restrictions on where you could live, and who can own property, and that, of course, those influences propagate. So there's an admixture of things that can happen at the policy level, but also there are things that can happen, in a grassroots cultural level that could move a lot of these things.
Yeah.
So, in addition to thinking about what the next policy that would be influential would be also think about how we could support and make into role models the people who are doing the type of work that we want to see ourselves represented in.
Yeah, absolutely. Couldn't agree more.
Yeah.
When I was at Vanderbilt University, and I was an adjunct at Fisk University, which is an HBCU, as you know, and there was a guy there I worked with, Dr. Brian Kent Wallace, who's a big player in the National Society for Black Physicists. And he used to come on the trips with me. I set up an astronomy roadshow. It's a big blow-up planetarium, and we go to all the schools in and around Nashville. And we specifically sort of went to the schools that had either they were in the poorest districts, had underrepresented minorities, just so that we could bring essentially what was a free education tool to schools that didn't normally have them. And of course, when Dr. Wallace came along, it was phenomenal because they saw somebody that looked like themselves in astronomy and in science. And I had a great rapport with all these kids. It was really cool. It was, I think, for them, it was just another white guy scientist. But when I took my,
some of those are my heroes growing up.
Of course,
of course. I used to again read the Makers of Mathematics. At that time, it was called Meta Mathematics, and read stories about how precocious Gauss was, correcting his father's engineering calculations when he was sitting in his lap, and how fecund Euler was with 1,000 papers back then, whatever that meant, and he also was fecund with having a lot of kids, and Archimedes drawing diagrams in the sand before the moment of his death, and I related to them in the sense that I was just very passionate about the same things that they were.
Yeah.
But there's the effects of representation may be very good as a diagnostic into effectively, giving you a measure of how much resistance different groups are facing.
Absolutely.
So you were hand in hand with the Fisk Vanderbilt NSVP professor who went to the community and was just having an effect by virtue of being in the community.
I think so. Well, he's also a really jovial fellow. He's my height, but he's a big man. But he's got this big personality, and he laughs a lot, and he tells a lot of jokes, and he's just a cool guy, right? And he was way cooler than me, let's face it, because I was sort of teaching them about astronomy. And, I have a silly accent for this country, but Dr. Wallace just had this great rapport with the kids. It was really fun. I saw him in Nashville about 3 months ago, and he's agreed to come on the podcast as well.
Oh, nice.
So,
and we do have this connection with the National Society of Black Physicists, and I have to plug my program that when I joined the Event Horizon Telescope in 2020, and actually I credit David for being instrumental in vouching for me to be an Event Horizon Telescope member, not without barriers, but we got it through. And I started a partnership between diverse national organizations. So I immediately wanted to take on the role of outreach group coordinator. And at that time, they didn't have a sense of tying together diversity and outreach.
That's right.
So the outreach was mainly just public outreach and just getting as much media coverage as possible. But in the United States, there happened to be tying together things like outreach and diversity. And that was part of what my notion of what it might have been was. But in the end, I, again, got through whatever bureaucracy happened at these types of collaborations, and I became the coordinator of the outreach group. And I also had meetings between the top management of the Event Horizon Telescope and the presidents of the National Society of Black Physicists, president of the National Society of Hispanic physicists, of
SACNAS?
Well, the Society for the Advancement of Native Americans and Chicanos and Scientists is SACNAS, but they have representatives at these meetings too.
Yes.
And when we tied the acronym soups together, we ended up making an insane alliance, so N-sane.
Nice.
And that also has significance to people who do simulations in relativity. Like there's magnetically arrested disk and standard normal evolution. So I
that was pretty clever.
yeah. So we have I used to focus on semi-mad simulations, but insane is another variation that you could think of as being the next type of simulation coming out there. But we had this partnership between the Event Horizon Telescope and these national organizations.
Excellent.
And lo and behold, 5 summers later, we're on our 5th cohort of a program where we select students mainly tied to National Society of Black Physicists to go to Harvard for a summer internship that often turns into a lot more than that.
Yep.
So, last year a student just published about detecting polarization around photon rings in the Astrophysical Journal Letters, and she came from the program that started in 2020. In fact, my postdoc, when he was doing his PhD at Harvard, we encouraged him to be part of this program, and he ended up, instead of leaving the field and making a lot of money in finance or doing tech, he ended up staying, and so he came down to Texas with me after finishing his PhD at Harvard, which was 350 pages long. It was very thorough and very good work.
That's a long
so we're happy that he stayed in the field to work on some of these sane simulations, to apply them to tidal disruption events, and to have that be a new thing for the Horizon Telescope. But each year we had 2 to 3 students selected from mainly the National Society of Black Physicists, and a lot of them kept up with their work because of making an intentional partnership with that. So that's another strategy. So in addition to the policy level, and now it's election season, so make sure that the candidates have to talk about that during the debate.
Yeah.
Make sure that they talk about education a little bit. I mean, I haven't really much discussed on that, but you can work on that. We can work on cultural ways of making this one of the most important things, to the point where we're like really proud to be scientists,
Right.
and that's part of our identity. And then there's the networking. So networking is I was surprised that there was so little resistance to having dedicated grant money, that's hard-won grant money, being attached to NSPP students, that I was like, why didn't it happen before? But it probably didn't happen before because everyone in these organizations are very busy, and they might not have the in or the link. Everyone in these collaborations are very busy, and they're only probably looking through and answering the emails of the people who are passing them by the hall.
Yeah.
But
I agree.
Those silos didn't have to be silos, and it really just took some intentional partnership, and that made a world of difference. And I think that I encourage people to look up this NSPP SAO EHD Scholars Program, duplicate it, and follow that type of model. I think that that's one of the really scalable solutions going forward. So there's a networking part of this that we can also go down.
I love it. So that was a really interesting discussion, Richard. I really like that, and you're well placed for that. And my career choices allowed me to be relatively well placed for that too. So I'm really glad we had that discussion. The interesting stuff in terms of your science, without using too much jargon, can you tell our listeners, what your science program is? It can't be done. I mean, not too technical, because even me, you'll lose. But our listeners are generally general public people.
So I started the first Event Horizon Telescope group in the state of Texas, here at University of Texas at San Antonio. And our group uses simulation, so the ones that had the funny acronyms like standard and normal evolution or magnetically arrested disks, to apply what we know about fluid dynamics and plasma physics to give realistic phenomenological models of what to expect is energizing the particles around black holes. So hopefully people here have seen pictures of black holes. Otherwise, we as Event Horizon Telescope would be failures. Let me see if I have any handy. Do I have any black hole memorabilia? Because really stylistic ones. Maybe if people have, this is like the crudest possible one, but if people have seen these types of memorabilia around, I don't know if the camera's going to pick it up here.
May not, but we'll put an image on.
But these are systems that I tried to coin a term because everyone's coining terms in this simulation-based analysis world. I coined the term jet, accretion flow, black hole system.
Okay.
Because these are really intertwined aspects of the environments around supermassive black holes, which we are able to actually see, not in just these cartoons, but actually see in images that we're going to edit in that show the billion-degree plasmas that are both inflowing and supplying magnetic flux to rotating black holes that in turn affect the dynamics of the plasma that could end up being ejected into some of the highest energy outflows that we know, which are relativistic jets.
Yes.
So the simulations that we have take hundreds of pixels on each side, which is not very much, to represent a region that is it's a few, maybe 10,000ths of a light year in extent, which is the most physically motivated unit that I could tell to readers.
Like solar system size-ish?
Well, so the event horizon of Sagittarius A star, which is the black hole at our galactic center, is about 7% of an astronomical unit in radius. So for a black hole like the one that we took a picture of in 2022, so me and David are in the collaboration that takes black hole images. So we took the first black hole image ever in MED7 in 2019.
That's right.
And then we took the first black hole image of our galaxy, black hole or supermassive black hole in 2022.
The data were actually taken in 2017.
The data were taken in 2017, but when we were confident we had an honest-to-goodness image from the data processing, were in those 2019 for MED7, 2022 for Sagittarius A star from that same 2017 data run. So 2017 was before I was in the collaboration. So Dave can speak to what efforts went into that part of it. But these systems, to get a sense of the size, instead of talking about units of tenths of thousands of light years, it might be more relevant to just picture this a black hole event horizon sitting in our within the orbit of Earth. And for the one that we took in 2022, that would basically be let's just make it simple and say 10% of the width of the Earth's orbit would just be occupied by black hole horizon.
So about 10 million miles, roughly.
That is then some 93 million miles to say 10 million. So astronomical unit about 93 million miles. And so now we have the English units that you wrought upon us, being from the UK. But okay, so now that you have several different ways of conceptualizing the size of these things, imagine measuring a simulation region in terms of units that are roughly the width of a black hole horizon.
Mm-hmm.
So roughly the width of that tenth of a solar system, tenth of an astronomical unit. So you can have the simulations extend out a few hundred of these in each direction, but mostly in the direction that's along the rotational axis of the system.
Okay, which for this particular image would
be here. Yeah. So having simulations that span, let's say almost 1,000 of these units that are roughly the size of the black hole in this direction, and then maybe a few hundred in each of these transverse directions, then you would probably expect to have a gazillion, that's probably one of those funny English units again, pixels to really represent every little feature, nook, and crevice that's here. Yeah. But through some miracle, we only need a few hundred along those gigantic expanses to really give us a picture of how plasma moves in these systems. So we've solved a lot of the technical problems of what we call magnetohydrodynamics, which is fluid dynamics that are governed by the same laws that the Bernoullis were pioneering hundreds of years ago. But we can really precisely describe the flow of a magnetized plasma using similar laws to that, but with the addition of some of the funny effects that Einstein predicted near the black hole.
Yep.
So having these simulations in that environment is already a monumental achievement. And with the competition between the amount of resolution you'd want in your simulation, so the amount of pixels you'd have between distances versus the amount of space you can cover, you actually want to cover this full jet accretion, full black hole system if you can. It's already a miracle that we could realistically simulate some of these plasmas. But here's where my group comes in. It's not enough to just know how parcels of plasma evolve, how their density moves around these regions, how the magnetic fields move around these regions, how fast each parcel is moving. That doesn't give you a unique image. In fact, if you look at a series of papers that are very characteristic of this, there's a series of papers that I started called On the Comparison of Active Galactic Nuclei with GRMHD Simulations. I applied this technique of actually lighting up the plasma with with plasma physics motivated ways to heat the particles that we're seeing at the frequency the Event Horizon Telescope is sensitive to.
So we can observe it.
So after you get this wonderful simulation, if you light it up in a way that makes the turbulently heated plasmas hottest at the frequencies you're observing, you get a much different picture than if you light it up in a way that you get when the magnetic field topology is changing, is governing how hot the particles get.
So we've got to be careful here because we're getting quite technical.
Yeah. So there are different recipes you can have that would light up one simulation in a completely different way than another.
Yes.
And we're frankly quite clueless as to what exactly is, with our blurry images, we can accommodate a lot of different physics to make them look to the level of blurriness that we have them.
So here's a thing, just so our listeners know. When we make mathematical simulations like Richard does, it's essentially you make a cartoon version, except it's computerized, of what you think is occurring in a physical system. Now we're able to observe that in some fashion of the real black holes, and then you compare what you think is happening in the simulation to the actual image, and then the differences tell you about some of the physics that goes on. Here's the real question. As astronomers, actually I think this is a fair question for astronomers, but also for the general public. Who cares?
Well, I hope that the public does, and I hope that, again...
But why do we care? Why do we care as astronomers?
Well, we want to get funding to do what we're doing.
That's not the answer.
No, so we need to eat. Come on. That's one reason.
That's true. But seriously, from a fundamental science point of view, why is it important?
Almost all of... I wanted to see you back in the time of the cave people asking, what are these imaginary numbers with these electrical circuits have to do with anything with my clubbing a rhinoceros?
That's fair.
So aside from just the intrinsic beauty of the satisfying nature of how it is to uncover the inner workings of the natural world, that's satisfying in itself. That adds some utility in its own right.
Yep.
But most of the applied math that is extremely useful to our everyday lives started off as pure math that we had no idea would have been useful. Okay. So again, I go back to the example, imaginary numbers. They showed up in things like there's an equation that Euler popularized, e to the I pi equals -1.
Mm-hmm.
So it had, if you bring the -1 over and you say e to the I pi, +1 equals 0, it has 5 of the most important numbers in the universe.
That's true.
So, the alien version of Euler would or whoever Euler stole it from would probably really memorialize that equation. But some of these numbers were the cave people were just counting using integers. So there are a couple of integers are in that. So you see 1 and 0 are in there. But what is this e? What is this I? What is this pi doing there? So okay, you can say that Archimedes had this fascination with trying to approximate the ratio of the circumference to the diameter by just inscribing and circumscribing polygons. So some human beings care about that stuff, but you can easily see some people shooing Archimedes away, telling him, why do you care about making that extra length segment of this n gone fit closer to this, no one's going to use it with as much precision. And then they're even worse, like there's e, and then there two transcendental number, e, and then and then now you have I, which is not even a real number.
That's right.
So they had so much things that you can pick on with such a even that one equation. But then they turn out to underlie our circuit theory. Solving circuits when you have exponentials, instead of bothering with trig, lets you power the camera that's that's showing it. So we're doing things to our planet and geopolitically that might make spacefaring a really important thing for future generations.
That's a great point.
So understanding this funny type of tracing rays from a very curved space-time might be something that's a life or death experience when we're trying to leave each planet we destroy successively. So
I'm with you, by the way. I was playing.
I'm playing one too. Yeah.
No, this is brilliant, because one thing I love about what you're doing is, I think one thing that's coming across apart from your intelligence is your passion. Like, you care about this stuff, and your fundamental knowledge is wonderful. But I think it's a valid question, because you and I know why we do it, and our families do. But if you were to stop Joe or Joanna on the street and say, "What do you care about? What astronomers do?" I don't know how many would say yes.
I mean, we've been sending a few people to the moon, but that's not going to be enough. I think that's it's an insurance plan for our planets. I think that's the practical uses that we'll have, other than inferring how high energy physics works with some of these jets are the highest energy discrete astrophysical sources out there. So think about 10 to the 37 watts. So a watt is something that, like instead of 10 to the 2 watts or something that these are powering, 10 to the 37 watts. We're not going to make 10 to the 35 light bulbs and do it. We're not going to do. The only place that we're ever going to really be able to test physics at those energies for the time being are going to be in relativistic jets.
Absolutely. Yep.
So we can make cool gadgets based on what we glean from these jet accretion-full black hole systems, but also I think that the vast majority of their utility is going to come from unforeseen applications, and I think that the flavor of these unforeseen applications is going to be, if we ever want to become a spacefaring civilization, we're going to have to master relativity.
Oh, absolutely. Yep, absolutely. Well, we've started. It's nascent, right? Because the GPS system has relativistic corrections.
You need to give coordinate patches over to different satellites and glue them away. But
so we've started.
Yeah, but we're actually gonna have to probably make shortcuts in space and time, and in order to really get far.
Well, that's where theorists like you come in, right? Because we need wormholes and string theory to help us with that.
We might not need an answer. The answer might be just staring us in the face. It could be how we got here in some sense. Maybe these big bangs are, white holes, or there are speculative ways that we could be the beneficiary of some of these technologies already.
That's true. So am I guessing correctly here? You think that the sort of seeding theory that
I'm not putting any money on any of these, but it's a really tricky thing to think about whether time itself is finite. So I mean, we somehow have a way easier time wrapping our heads around space being finite than time being finite, but roughly they're two sides of the same coin.
Yeah.
So time might very well be a property of this visible universe, and it may be finite. And then other physics might go on in the absence of the 3+1 space-time dimensions that we think are the extended dimensions here.
Mm-hmm.
So string theory string theory could be more of an allegory for how you could make certain dimensions small, and it's probably going to be looked at the way that people look at epicycles when
Right.
We're trying to come up with planetary motion in a way that were consistent with what we knew at the time.
Mm-hmm.
But it turned out that there was something much simpler.
That's right.
That Kepler showed you. You didn't need all these circles going on top of each other. You just need to think about ellipses and foci and but yeah. So but string theory does have good elements in terms of pushing our understanding of mathematics and pushing our understanding of topology and geometry, and the things that we might be able to learn from that is that maybe hiding dimensions, or if you want to use jargon, maybe compactifying dimensions and maybe having extended dimensions is something that might happen between let's just call them walls of a multiverse. So maybe there are some places where you can gain a dimension here and there,
right?
And if you have a case where you started out where at a point that we think is zero dimensional, it might not be that way forever, or there might be some way to just turn on a few dimensions and make things expand. There might be ways to make things contract back.
Yeah. We need Tony Stark at this point, basically.
Yeah, we
definitely need Tony Stark. All right, let's move on a little bit. If this is a good
question, probably should cut that out. Like that.
No, it's great. This is why we're doing the podcast, man. This is you're great at the mathematical stuff. You've got the passion.
No, but it's not on firm footing that the dimensions could appear or reappear.
Of course not. But we're humans who like to dream as well, right? If money were no object, or circumstance were no object, would you still do astronomy? And if not, what would you do?
Well, maybe not as much, but I would still, there's certain bureaucratic tasks that I wouldn't be doing. I wouldn't be writing grants if money were no objects.
Well, that's true too.
But that's probably like 40% of what I do at this point. So so with that other 40%, maybe a little bit more will be pure research. But then, definitely astronomy will be part of my lifestyle. Yeah.
Well, as you know, I do most of my work in industry these days, but I still use the telescopes every couple of nights a month. It's never going to leave you. If you went into industry tomorrow, or you set up your own company or won the lottery or whatever, you're going to do astronomy for the rest of your life. It's in you.
There must be some astronomers who have won the lottery. Let's see what they actually did.
Right. If they did, they're not telling us. That's for damn sure. That's it. I think I agree with you. Are there downsides to being a professional scientist and educator?
I already mentioned grant writing.
Grant writing, that is harsh. Yeah, it's actually not that bad, but it takes so much time.
It's actually that. Well, yeah.
Just to be clear, by the way, for our listeners and readers and viewers, writing grants is basically how you get funding from various agencies to support the work you're doing, pay salaries of your students, your postdocs, that kind of thing.
Yeah, certainly. I mean,
faculty committees and.
Yeah, committees. I mean, I also, I do wish that people were more concerned with the subject itself rather than using it as a requirement or
I see. Yeah.
Or something that you paid for, so you have to do. So if there was some more buy-in, I don't know why it's gotten into popular culture that physics is the worst class, or people have to dread physics. I think that.
Yeah, you know what? I think I have an answer for that. I think it's changing, but I think historically people have taught physics and especially mathematics in a quite complex way. Where with my own children at home, I always tell them mathematics is a game. That's all it is. It's just as you use language, or you balance a ball, or you play in the sand. Mathematics is the same. If you can juggle numbers, if you can convert, fractions into decimals, and you can do trig, and you can do geometry, if you're able to juggle those things in your head as like a game, the work you and I do is not that complicated. But I think historically, mathematics especially has been taught very, very rigidly and not in an understandable way. So I think if as scientists and educators, if we did a better job in teaching maths better, there's such a lot of mathematics in physics. And I think, again, we teach physics from a maths point of view instead of from a concepts point of view. And when you do concepts, I think it's not a difficult subject.
I think there's an even, completely orthogonal direction you can come at this from. Maybe just having some examples of some of the great technical accomplishments that some people might just be in awe at how a teenager could use just a compass and ruler and make a 17-sided polygon.
Yeah.
So some of the amazing achievements that mathematicians or physicists have done. Seeing how Einstein developed relativity almost as a fully mature branch of physics, when you can think of like 10 people who were responsible for the quantum revolution, and Bohr, Heisenberg, Schrodinger. You can think of all. So I think about the one person who's achieved almost a fully formed branch of physics, and how can you not be in awe of that?
Oh, yeah.
And the actual technical things of in some sense viewing space and time on the same footing, or all of the different ways that relativity has challenged assumptions that we thought were almost unassailable. Having people just appreciate those and appreciate how complex and how amazing the accomplishments are. Maybe just the biographies of mathematicians and physicists would be one of the other, another direction to, maybe on the instructional side, having the concepts rather than showing people an inclined plane or a pendulum and asking them what the period is, or what the velocity of this box down a ramp is, but instead, just think about a law or an interaction. Gravity, it's one of the fundamental interactions, but it's so different from the other three. It's the one that can't right now be expressed as a quantized field. It's the same force that is holding the planets together as it's holding us to this planet. That could be one thing, but then also getting people to actually appreciate how monumentous some of the computational Tudor forces that have occurred that made all of our technology possible, and just like how impressive some of the achievements that have been made. Like let's talk about LIGO. I can plug in the other collaborations too. LIGO, and imagine having a strain that's like 1 part in 10 to the 21 or 10 to the 22 of the object itself.
Yep.
In an engineering sense, in a sense of the theory that goes behind understanding what the chirp frequency looks like, having felt a wave for the first time, having a strain instead of something that you're seeing in terms of electromagnetic wave, having a gravitational wave create a strain for the first time that you detect. I think that waiting in the complexity of it sometimes could be another way to get people in it.
Absolutely. And also, and I'm really glad you brought this up, things like this podcast, so showing the general public or showing the public at large that astronomers, scientists are real people. They've got rich cultures, rich backgrounds, interesting stories. They're passionate, which you've been sort of shown as your passion for science and for astronomy. I think that's so important. And so that's why I was thinking about this series of all the astronomers I know, because the average astronomer is a pretty cool person. They've got an interesting background. They're intelligent, and they love science, and they want to share it. And I think you're right, that biography thing, just tell the people who ultimately fund us with their tax money, right? Why we
or the subscriptions.
Or the subscriptions. There you go. There you go. Thank you. Good advertising. But really, why we do the work we do. And I think when they see the passion with which we do it and how rigorous we do it, We don't take shortcuts. We're honest, and if it takes 10 years to do, we'll take those 10 years to get it right. And I think that's so important. I'm really glad you mentioned that. All right, I've got two more questions. One that is really easy. One's hard. What is cool about being an astronomer? Well, I think you just answered it, but what is cool about being you as an astronomer?
The non-grant part. Being able to think about how, being able to, one, contribute to, and two, think about the very inner workings of the universe for a living is pretty cool.
I agree. Couldn't agree more. Yeah, you've sold me on that one. All right, this is a harder one, and you don't have to answer instantly. In fact, you may not want to, or it might take some time. What would you go back and tell your younger self?
Depends on how young. Not to eat that burrito, or
okay. So that's a scientific answer. I didn't quantify how far back. Okay, let's say your 10 or 12-year-old self. You're just developing into this sort of little human who's able to really have cognitive thought, decide their pathway in life. Let's say 10, 12, maybe, I don't know, something of that order.
I don't know. Keep being a thorn at people's side. Don't just accept what the authorities are telling you.
I like that.
That could very well work for a lot of people, but if you just do what's prescribed for you, then you're not going to be living to your potential. Don't get in too much trouble, but it's only worth it if you just continue being you. And there are going to be a lot of skeptics, a lot of people that don't immediately, or if ever, fall towards your side. But if you're when you're motivated by I guess long held and no, I'm not gonna. Let's see. A lot of people can have a sense of like they're on the right path, but don't let the criterion of whether you're on the right path or not be dictated by what other people who don't know you very well are telling you.
I agree. I told you it's a hard question. You did a good job.
You can cut out some of the gaps.
No, most things we're going to leave in because you know what? That's you being you and being real. Mm-hmm. If this was super polished, I don't think it would be as authentic. Mm-hmm. I want, and I'll probably leave this part of the speech in too. I love the fact you're being a real, excited, passionate human. Mm-hmm. And I did mention that was a really tough question because it's one we're not asked often. Mm-hmm. Obviously, we can't go back in time, but it's to have regrets in life is terrible. But you think, was I given the right advice when I was younger? Would I have taken it? Was I too proud? Or was I not in the right circumstance? Or did I not listen to my mother? Or did I, when somebody said it can't be done, you did it because you had pride and determination and intelligence. So I think what you said was a really good way of addressing it.
Some things you should listen to, but
yes.
but some really firmly held core beliefs that took you a lot of effort to arrive at shouldn't be overturned very easily on the advice of a lot of people who might want to weigh in, but who haven't gone through much of what you took to arrive at those specific things.
I couldn't agree more. Be honest, be kind, respect everybody. With that, Richard, I think we're pretty close to the end. I've dragged you over the coals quite badly there. I'm really grateful that you agreed to do this with me. I hope we can do it again.
Anytime.
I'd love to, because you're such an interesting fellow. You are Dr. Richard
Anantua. Yeah, you said it reasonably well.
Sorry, yeah, I've always thought whether I pronounced your name correctly.
I think it's reasonably well. Anantua.
Anantua. I think I've always said Anantua. It's
here. Yeah.
Anantua.
Okay. I think you did
okay.
Good enough job.
I apologize for all the times
to order of magnitude. Yeah,
that's right. Well, I'm British. We don't do well with languages normally. So this is Dr. Richard Anantua.
Yeah.
from the University of Texas, San Antonio.
And David James of...
There you go. You could do the same in return.
I'm just teasing.
An old friend and an old colleague, and I hope that we'll definitely do this again.
Yeah, thanks a lot for the opportunity.
You're always welcome. Thank you.